Pilots, welcome back to Mickey BRC. Thank you so much for tuning in on what is another helicopter video. The last video I did was of the Bell 222. Now, unfortunately, that suffered a little bit of an accident. It wasn't even flying related. It was really silly. I moved it out of my office to do some cleaning, and I kind of forgot that the cat is afraid of the vacuum cleaner. Well, one thing led to another. Cat tried to jump over the helicopter, misjudged it, and tore the tail off.
No, God!
So perhaps in another video coming up soon, we'll learn about repairing fiberglass. But anyway, we do have another machine on the bench. This is another offering by Roban, another 800 size, and it is the EC-145 T1. So if you just excuse the mess on the bench there, here she is, the EC-145 T1. Now you'll probably notice on this particular Eurocopter that it has a conventional tail rotor system, unlike the other EC-45s, which you've probably seen. Probably more common is with the Fenestron tail. This one here is, I believe it's closely related to the BK117. I can't remember whether it's their C2 or B2 variant, but the T1 is pretty much the same as the BK, which I absolutely love the BKs. Such a cool shape, typical of your rescue helicopter. But anyway, you can see here, this isn't how it comes out of the box with Roban. This is a whole new scheme. I've actually done one through Helio Otago. So this is an Otago rescue helicopter, which is based at the South Island of New Zealand. Helio Otagos run a suite of ECs, and I believe a couple of the aircraft as well, the BKs. So this is the one that I sort of chose. So this model I've been working on for a couple of months, mainly to get all the paintwork done, the decals, and all the 3D printed parts. I'm thinking this is going to be one of those projects which is never quite finished because of the use of 3D printers now. I got a new FDM printer and I absolutely love it. It's so good, it's so handy to add in scale detail and that into the machine. But anyway, let's jump in. We'll open it up. We'll talk you through the EC-145. Alrighty, we'll start from the front and work our way back on this one. So underneath, got some detail here. You can just make it a spotlight there. We'll talk about that in a moment. Some 3D printed parts, some aerials, and then we move our way into the cockpit. This panel here, that's 3D printed as well. And inside the cockpit, this is all stock. So this actually comes with the model of the seats, the collective, cyclic, pedals, and of course the panel up here as well. It's all two pieces, this panel. So you've got the lower panel here and this top panel up here, which separates, and they're all backlit as well. You can just make out on the screen some detail there, but there's actually some LED lights behind that, and it lights up when you turn the machine on. Locking doors, which is kind of cool. Got a sliding door back here, and then we've got the interior. The stretcher and the rail for the stretcher is all 3D printed. I got a panel up here which contains some medical equipment. There's also, you can just make out the back side here of another panel, and also we've got a cabinet with various components to it. This is magnetically held, along with a stretcher as well. It's magnetically held. This is just a medical cabinet, some sort of scale detail. Bags are magnetically held as well in case I want to change anything out. But otherwise, yeah, that's it's only in there. I'm still undecided whether I want to fly with all this stuff in it, but if I have the option of removing it if I do want to remove the flight. Underneath here is where the battery sits. The battery sits actually underneath the cockpit, right at the front, and plenty of room back here for if you wanted controllers and that, but I don't have any of this, just the wiring for the batteries, and also this lamp here, wiring for that goes up and into the doghouse. So move on back, we've got some bear paws, gotta have those, and moving on to here, we've got some, you can see that, just another 3D part, printed part, basically like the exhaust section of the turbine. And then the tail section here. We'll go into the lighting in a moment. I'll also open up the doors here. The doors are magnetically held. There's another, it's like an oxygen cabinet thing there. And that's also magnetically held. I'm thinking about maybe putting a servo into the doors to open them and close them. But for now, it is magnetically held. Roban kind of have it's like a bolt that goes through there. You would screw it and there's like a hook that goes round into a pin. I don't really like that idea in case I need to get in there quickly. I don't see why I would, but if I did, the magnets just work. So we'll open up the doghouse. Also, you notice here is a winch. This isn't functional, it's just for show. It's just a 3D printed part. It looks like it's functioning because I put a wire here, but that's just loosely on there. And I can remove this for kind of transport. One thing I do like about the EC is how the doghouse splits here on either side of the rotor head. The Bell 222 doesn't. It splits, I think, from here forward and then back, which means to get to the head and that you're going to have to take all of this off, the head off, to then get the section of the doghouse off. Yeah, this works out a lot better doing it this way. So we'll just separate them. And then we've got all the electronics. Let me talk you through what we've got here. So we have an Ego Drift, I think it's from their scale series. This one here is a 4230 520 kV running on 12S. And then as we move back, we've got 3 ARFC 42 kg digital high voltage servos, and then powering the tail is another ARFC, and that is a 25 kilo servo, I believe. So powering the machine, I've still got to fix this in, is a Castle Creations 20 amp, get out of there, BEC. At the moment I've programmed this to about 7.4 volts. I may increase that because I'm kind of running this off 3S, so that's stepping it down to 7.4. Everything here can run off a higher voltage, so I think I'll increase that just so there's more grunt up here for the servos. And moving on back, we've got a Castle Creations ESC 160 amp. That just feeds the motor. This will feed the receiver and also the fireballer system. Fireballer system, I'm testing this flowing H1 Pro for this one. It seems to be okay so far. I'm a little bit sort of wary of it. I wouldn't say I'm apprehensive, I'm just a little bit wary and wanting to do things very, very slowly. In the Flintstone Flyer configuration, which is basically for those who don't fly helicopters, you're pretty much just flying the mechanics through in the tail section, and it's probably I had mine sort of bolted to a couple pieces of wood and just the flight batteries and the receiver pack, nothing else. They call it a Flintstone Flyer, or it's really bare bones pretty much. It's a good way to test everything. It seemed to be okay with that. I've got GPS and everything for it, and no vibrations or any sort of weird tendencies. But with this in the whole machine, I don't know whether weight may come into a factor. Just the shape of it may sort of affect the performance. Who knows? So I'm testing it very, very slowly, very methodically. The good thing about the ESC, the BEC, and the H1 is they're all programmable. Even the servos are programmable individually, which is really, really handy in terms of centering and throws and stuff like that. I don't need to always do it through here. I can actually do it through the servos themselves. So the H1, for those who, again, not into the heli world, this is GPS capability. So this wire here goes to a GPS module. There's an internal compass in here. So effectively I've got 3 modes. I've got GPS, which will make it fly like a drone. And then you got attitude mode, which doesn't have the GPS lock, but it has the stabilization. And then you've got like a 3D mode, which there's still stabilization there, but it gives you a lot more freedom. And then back here, we've got an 8-channel Unilight controller, which powers all the lights on the model, and they're all programmable. I've programmed the sequence, the timing and stuff like that. Really cool. We'll get into that on another video, programming this. It's such a cool component to add for scale and things like that. A lot of the jet guys use Unilight here in Australia. I've seen it's quite popular in Europe, and I'm sure it is in the US as well. So very, very cool component down there. That's, yeah, like I said, you can plug that into your computer, program your light sequence, and it gives you a whole bunch of functionality. So going back, as I mentioned, Unilight, obviously. So I've got some nav and strobes on either side of the verticals here. I've also got a couple of strobe lights here. You can just make out between my finger and thumb. And then there's a beacon up here. And then there's another strobe back here. And obviously there's the nav and strobe on the other side there as well. I've taken this from the scale version that this is modeled off. The Otago Rescue Helicopter. I sat there watching videos. There's only a couple of videos trying to get the light sequence and all that kind of correct. So yeah, it's very cool to be able to do that with the lighting system. And then under here, we've got like a search landing light. On the full size is another landing light which is flush against the body and it points down. I ordered something from Unilight for that, and unbeknownst to me, it requires a heatsink, which is quite bulky. And as you can see, my flight packs are right up the front. They're a bit loose at the moment because I haven't put any Velcro in. But even with the, just make out, that's the landing light. Ooh, it's a current spotlight landing light there. I would have to put, basically where this battery here is, if I wanted to go scale, that's where I would have to end up putting the other light, which sticks out quite a bit, which means there wouldn't be enough room for my batteries there. Even though it looks like a lot, or quite wide, yeah, there isn't too much there, because I've got to put other batteries in there as well, like my flight packs, my receiver packs. So one thing I've been getting into recently is, kind of saving my manuals for my models in clear files. You can buy these clear files like really cheap off Amazon or eBay. Really handy to have. And as soon as I get the model, you can notice some ticks here. I will put the parts which you get in the hardware kits for your models into one of these things here. Just a parts tray, which again you can buy from Amazon. It's really cheap. And I will label them according to what the manual has them labeled as. You can see some numbers there, some extra pieces. Most of the hardware I do replace with my own kits. So a lot of these are just spares. So those numbers correspond to a number in the manual, which does get called out here in the manual as well, which is really handy. You get these packs, hardware packs, just like with any model. So it's good. I go through with a pair of calipers, especially for the this type of hardware, the bolts and screw, well, they call it screws. Here, because there's a whole bunch of them, it's good to get some measurements of it to make sure, do I have an M316? Do I have the M3 nuts? 4 that sort of thing. And it's just easy to label them as you're going through the manual. With these manuals, it does pay to take your time and read through basically all the suggestions. Some of it is a bit funny though, in terms of what they're suggesting. Like some of the measurements here, there was these measurements here, this is what I was looking for. The 81, 112, 81, that's one, the 112, I don't even think it's achievable. But also, they don't factor in that, you go up to their head. So this is what they're talking about, 81, 112, 81, the length of these rods. What they don't factor in is this is offset. So it's actually 81, 81, 81 kind of thing. I put some new hardware in for these because I didn't trust like just normal ball joints onto the servos. So I wanted something that I can stick a bolt through. So yeah, all you want to do basically is this here should be at right angle, so it should be a 90 degree from here to here. And same thing with these arms here as well. And that technically in their manual should give you that 81 mil, 81 mil from center to center of the ball joints, and 81 to there, roughly. I would eye it from here, and using a swash plate leveler. If you don't have one of those, this is what it looks like. So with the head off, you slide this down the shaft, and these three tongues, I suppose you call it, if they mesh up on here, all three of them, all three sides touching with this part of the swash plate, you know that that's level against the shaft. This is a really handy tool to have. After that, once you level your swash plate, you're then going out to the blades, and I have a digital pitch gauge which I power everything on, have everything centered, and we'll have each blade from front and back and from left to right set at 0 degrees. So that way you know that the blades are absolutely level when everything is neutral. So again, for the setup, these should be at 90 degrees to each other. So basically a line up here with the shaft, basically. And then the servos should also be at 90 degrees as well. So ideally, that's pretty much the setup. And having tools like this and the digital pitch gauge really makes life so much easier in setting this up. Another thing to note in the manual and in the model itself, all these bolts here on the side plates on either side of the mechanics here typically don't have Loctite in them. So if you haven't got one already, I would suggest getting a paint marker, and as you undo each of these bolts and Loctite them, mark them so you know that they've been done, because there's a lot of them. I believe Roban kind of expect you to remove this when you get it to fit in things like your pinion gear, your motor, and things like that, and obviously your servos to adjust. You don't need to. You can actually get away with not undoing everything, but I definitely would suggest that you take the time to take one bolt off at a time, Loctite it, put it back in, and then mark it. It just makes things so much easier. The head typically does have Loctite in them. Even the blade grips, that I found this one was really good. Just be careful though when you do undo some of these bolts. They are saturated in Loctite, and it wouldn't take a great deal of force, especially for something like these, to snap the heads off. So be very careful when you are removing these. That's why I have my own hardware just in case anything does snap or break. I can drill it out, tap it if needs be, and then put a new piece of hardware in. Yeah, so I'm really impressed with this model so far. Belt driven, so you do have to play around with the tension on it, which comes from the motor. You can see here there's a bolt which moves the motor back and forth, and you've got to tighten it up. That'll set the tension for the belt. You don't want it super tight, but you don't want it super loose either. So you got to play around with that. Obviously, you don't want the belt skipping teeth or moving up and down this gear or the pinion while it's moving, while it's spinning. It's not a good day for anyone. But yeah, going back to the Loctite, make sure you Loctite everything. Last thing you want is anything unwinding during flight. There's quite a bit of vibration that can develop in these things. Bolts unwinding, getting into here, it's a bad day for you. It's probably going to cost you your machine if you're not worried about it. So definitely take the time to Loctite. The next few phases will be some more testing. The H1 controller, I really want this to work. Maybe to say it can be done, you just need to follow these steps. For the most part, it's been pretty good. But if towards the maiden with everything on, that I don't feel comfortable, or if it does something a bit iffy, I do have a Bavarian 3X fly ballast controller, which I'll just throw into it. This is what I was using in the Bell 222. So again, a few more flights, a few more run-ups. The next video, which I'll show you towards the end, is the run-up of the weekend just gone. And yeah, pretty happy with it. It's stable. A few quirks with the fly ballast, the H1 fly ballast controller. Things like don't set up your model as a helicopter in your transmitter. It sounds weird, but all the mixing and everything is done through the controller. One thing I was a bit about was you can't set the RPM. It just sort of does it on its own. The only way I could find you could set the RPM was to go through the ESC and say, I don't want you to go higher than 1100 RPM. At the moment, that's what I've set. And then in the fly ballast controller, you can actually send a percentage up from that. At the moment, 1100 seems to be the sweet spot for this. I won't know until I get it up. If it's sluggish, then we'll kick it up. If it's too much, then obviously we can bring it back down. So yeah, set up the model as an airplane or drone. That's what it suggests in the manual. A little odd. The rotor speed, yeah, you're probably going to have to play around with that. When I first put it in, all factory settings, it was the rotor head was going at 1450 RPM, which is way too much for this. I didn't need that much. We're not doing 3D with this helicopter. It is to fly scale. It is a big, wide, sort of girthy machine. So yeah, the lower the better, but you obviously don't want it too low, otherwise it will be sluggish in the air. The GPS and compass and that, I've had to recalibrate quite a few times because I keep programming it. There's some quirks in the controller or the software that if you set up a new model, you can't save your settings. So as soon as you go to set something up or set a new model up, everything gets wiped. So, Flywing, if there was a way to set up to capture those settings, have them saved so you can kind of load it in, that would be so much more easier, because that way you can have a bit more functionality, a bit more playing around with it. Otherwise, I'm just taking photos of the parameters on my phone, change things, test it, take more photos, that kind of thing. That's how I've been progressing with the model so far. At this stage, I think it's about where I want it to be. Couple more things which I want to do before I get it off the ground. I've had it light on the skids just to sort of get a feel for it, but you won't know until you send it, really. And that's going to be, yeah, it's going to be a nerve-wracking day, but I'm trusting the settings which I have so far and the components. But like I said, if I don't like the feel of it, if I'm not comfortable with it, then I'll just go back to the Bavarian Demon 3X fly ballast controller. Anyway, thanks for watching, and I'll leave you here with just a run-up of the machine, which I did yesterday after, yeah, it would have been, so when you're seeing this, it was the day before when I did this run-up. Nothing special, it's just a run-up of the blades just to make sure there was no vibration through the machine or any sort of weird tendencies, and it was mainly for blade tracking. I've had to kind of play with the blade tracking a couple of times for this one, just to get it settled. It's so close. So once I am happy with the tracking of the blades, then I believe it'll be ready for a maiden. But also to go with the maiden here in Australia, because of the model size or weight, I haven't actually even weighed this thing yet. The manual says it's going to be around about 8 kilos. Batteries in or out, not too sure. I assume it's batteries in. So I've got to weigh this, and models over, I believe, 7 kilograms here in Australia need like a heavy model certificate. So the maiden is combined with the certification. So doubly kind of nerve-wracking, because you know your maiden is going to determine whether the model's going to get certified or not. So yeah, that's why I'm taking things slow, doing things methodically, checking everything so many times and rechecking it again, just to make sure that it is absolutely perfect, or it gives me the best chance of success. But anyway, I'll leave you here with this video. Thanks for watching, and we'll see you at the field.